Hello students, in previous lecture we have learnt the concept of motion and rest, physical quantities, their definition and mathematical forms. We also learned the equations of motion for constant acceleration and their mathematical derivations. Before starting the graphical representations of relation between physical quantities, let us solve some numericals based on equations of motion for constant acceleration. They are equations of motion for constant acceleration. This is very important to keep in mind. These equations are, which I will write for constant acceleration only. First equation we used to write v is equal to u plus at. Here v is final velocity, u is initial velocity, a is constant acceleration and t is time. Now second equation what we write generally is ut, s is equal to ut plus half at square. S is displacement and u is again initial velocity, t is time, a is constant acceleration. And third equation what we use is v square minus u square is equal to 2as. U is final velocity, v is final velocity, u is initial velocity, a is constant acceleration and s is displacement. Let us first understand what is given in this question and what you have to find out. The question is, a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration. Here 18 km per hour is initial velocity and 36 km per hour is final velocity. And time given is 5 seconds. We will write it. Given u is equal to 18 km per hour and v is 36 km per hour and time given is 5 seconds. Now see here, the velocity is given in kilometer per hour and we should change it in standard international unit, that is meter per second. To change that, see how we calculate and find out. 18 kilometer will be written in meter by 18 multiplied by 1000. This is in meter. Now hour is written in second. 1 hour is equal to 60 into 60 seconds. Therefore, in the denominator we have written kilometer in meter and hour into second. Therefore, this is in meter per second. After calculating this, we will get what? Just cancel out and this is 5 by and this will be 3 and we can write it 18 multiplied by 5 by 6 into 3, 18. in place of 1000 by 60 into 60, directly we can write 5 by 18. When we have to convert kilometer per hour into meter per second, simply we can multiply this numerical value by 5 by 18. And this will be equal to 5 meter per second. Again we see in this case, in case of final velocity is again in kilometer per hour, and to convert it we will write 36 kilometer into meter. We have to multiply it by 1000. And to write hour into second, we will write 60 into 60. Only this part we will calculate or we will solve, then we will get what? 5 and this is 3, and this will be again 36 into 5 by 18. Then when we have to convert kilometer per hour into meter per second, simply we have to multiply by 5 by 18. And why we are multiplying this term by 5 by 18, you can explain in this way. Okay. Now cancel it. This is equal to 10 meter per second. Now we are having all these terms in SI unit. Initial velocity meter per second, 5 meter per second. Final velocity also in meter per second, that is 10 meter per second, and time is also in second. Now we have to put the proper formula and we have to calculate, then we will get the answer. The formula we will use is A equal to final velocity minus initial velocity by time. This is according to the definition of acceleration. Now put the values. 10 minus 5 by 5, and this is equal to 1 meter per second square. You must put the unit at last. This is very important. What you have learnt here? You have learned to convert kilometer per hour into meter per second and put the value and get the result. Meter per hour is initial velocity and 36 kilometer per hour is final velocity. And time given is 5 seconds. We will write it. Given U is equal to 18 kilometer per hour and V is 36 kilometer per hour and time given is 5 seconds. Now see here, the velocity is given in kilometer per hour and we should change it in standard international unit, that is meter per second. To change that, see how we calculate and find out. 18 kilometer will be written in meter by 18 multiplied by 1000. This is in meter. Now hour is written in second. 1 hour is equal to 60 into 60 seconds. Therefore, in the denominator, we have written kilometer in meter and hour into second. Therefore, this is in meter per second. After calculating this, we will get what? Just cancel out, and this is 5 by, and this will be 3, and we can write it 18 multiplied by 5 by 6 into 3, 18. In place of 1000 by 60 into 60, directly we can write 5 by 18. When we have to convert kilometer per hour into meter per second, simply we can multiply this numerical value by 5 by 18. And this will be equal to 5 meter per second. Again we see in this case, in case of final velocity is again in meter, a kilometer per hour, and to convert it, we will write 36 kilometer into meter. We have to multiply it by 1000. And to write hour into second, we will write 60 into 60. Only this part we will calculate or we will solve, then we will get what? 5 and this is 3, and this will be again 36 into 5 by 18. Then when we have to convert kilometer per hour into meter per second, simply we have to multiply by 5 by 18. And why we are multiplying this term by 5 by 18, you can explain in this way. Okay, now cancel it. This is equal to 10 meter per second. Now we are having all these terms in SI unit. Initial velocity meter per second, 5 meter per second. Final velocity also in meter per second, that is 10 meter per second, and time is also in second. Now we have to put the proper formula and we have to calculate, then we will get the answer. The formula we will use is H equal to final velocity minus initial velocity by time. This is according to the definition of acceleration. Now put the values. 10 minus 5 by 5, and this is equal to 1 meter per second square. You must put the unit at last. This is very important. What you have learnt here? You have learned to convert kilometer per hour into meter per second and put the value and get the result. Now come to the question second. See what is given here. A train is traveling at a speed of 90 km per hour. Here the 90 km per hour is initial velocity of the train. Now brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Means the final velocity of train is 0. Finally the train is stopped. Now let us see what is given or write. Given the initial velocity is 90 km per hour. As the acceleration is given in meter per second, we have to convert it into meter per second. And what we will do here? 90 is directly multiplied by 5 by 18. Why we multiply by 5 by 18? All of you know. Now cancel it. And we will get the value 25 meter per second. Acceleration given in the question is minus 0.5 meter per second square, and the only this it is given, time is not given. Now you have to find out the distance traveled, and final velocity is here 0. Which formula will work here? there are 4 physical quantities and one you have to find out. Then you have to judge which formula you will select. Then certainly you will select v square minus u square is equal to 2as. Here 4 variables are there. Final velocity, initial velocity, acceleration and distance traveled or displacement. And out of these 4, 3 already we are having. Initial velocity we are having, final velocity we are having, and acceleration also we are having. So we can use this formula. Now put the values. Final velocity is 0. 0 square minus initial velocity is 25. 25 square is equal to 2. Acceleration is minus 0.5 into s. Here 25 into 25, 625 minus 1 into s. Then s is equal to, negative sign is also here, so negative sign will be cancelled. Then distance travel is 625 meter. This is the answer. Now let us come to the third question. A racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after start? Here you have to find out the distance covered. And the initial velocity is not given. And it is written after start. Means it has covered a distance with initial velocity 0. If the numerical value is not given, the numerical value of initial velocity is not given, and body covered at certain distance, that means body has started with initial velocity 0. So we will take here initial velocity 0. Given initial velocity is 0, acceleration is 4 meter per second square, time is 10 meter per second, and distance travel you have to find out. Again 4 variables are there, and out of 4 variables already the value of 3 you are having. Which formula will suit here you have to choose, and I hope you will choose s is equal to ut plus half at square. Here all these 4 variables are coming in this equation, and s you have to find out. Now put the values and get the result. 0 into 10 plus half 4 into 10 into 10. Now this is 5. This will come 0 plus 200. Then displacement is 200 meter. Come to question number 4. A motorcyclist drives from A to B with a uniform speed of 30 km per hour and returns back with a speed of 20 km per hour. Find its average speed. Here you have to find out average speed, and to find out average speed we need total distance traveled by total time taken, because we know average speed is equal to total distance traveled by total time taken. Here the distance between A and B is not given in question, and also the time taken from going A to B and returning back from B to A is also not given. These two, distance travel and time taken, we have to assume and then we have to proceed. Let us do that. Average speed is equal to total distance traveled by total time taken. Let us assume a distance between A to B is x and time taken to go from A to B is t1 and time taken to return back to A. Now t1 plus t2, that is the total time taken to cover complete journey, is equal to x by 30 plus x by 20. The LCM will be 60, 2x plus 3x and this is equal to 5x by 60. Now we will put these two values, total distance traveled and total time taken, in the formula of average speed. Average speed to complete whole journey is equal to total distance travel x plus x and total time taken is this 5x into 60 and this we can write 2x by 5x into 60. Now cancel. This is 120 by 5 and this is equal to 24 kilometer per hour, because average speed we have taken in kilometer per hour, so the answer will be also in kilometer per hour. Now this is question number 5. Let us see what is given here. A car starts from rest and moves along the x-axis with constant acceleration 5 meter per second square for 8 seconds. If it then continues with constant velocity, what distance will the car covers in 12 seconds since it starts from rest? Means what? The complete journey of car is of 12 seconds and this 12 seconds is divided into two parts. The first part is 8 seconds in which car moves with constant acceleration and the last 4 seconds it covers with constant velocity. In case of constant velocity, acceleration will be 0. Let us proceed. What is given? As car starts from rest, then initial velocity will be 0. Then the acceleration is given 5 meter per second square and time is given. That is 8 seconds. Which equation we will use? S is equal to ut plus half at square. Here the initial velocity is 0. The 0 into 8 plus half 5 into 8 into 8 and this is 1 160 meter. Let us assume this is S1. Now for the last 4 seconds distance travel I will take S2, and for constant velocity the formula will be what? The u into t, because acceleration is 0. Now the u is, we have to find out. U we have to find out here, because after 8 seconds the velocity of car has been changed due to acceleration 8. So this v we have to find out with help of formula v is equal to u plus at. And this u is v. Better to write this u as a v. Means after traveling 8 seconds, the velocity of car becomes v, and rest journey that car will complete with that velocity. And this will be equal to u is equal to 0, acceleration is 5 and time taken is 8. And this is equal to 40 meter per second. Now S2 is equal to 40 into 4, the time taken by the car in last 4 seconds. So this is 4 and this will be equal to 160 meter. Therefore, the total distance travel equal to S1 plus S2, 160 plus 160 equal to 320 meter. Now come to question number 6. A ball is gently dropped from a height of 20 centimeter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? You have to find out the velocity with which the ball will strike the ground and the time taken to strike the ground. But before solving this question, let us see what will be the form of equations when the body is falling freely near to the earth. Because near to the earth, the acceleration due to gravity is taken constant. So let us see. For freely falling bodies, v is equal to u plus gt. S is equal to ut plus ut plus half gt square, and v square minus u square is equal to 2gh. Here in place of distance travel we will take height, because from certain height the object is falling, and this is the case when the body is falling in downward direction. Now when the body will go in upward direction, then we generally take u minus gt, h is equal to ut minus half gt square, and v square minus u square is equal to 2gh. The acceleration will be negative here also. Understand? Now we will solve this equation. Now let us see what is given. Given ball is dropped gently, means the initial velocity is 0, u is equal to 0. Acceleration given is 10 meter per second square, and final velocity you have to find out. The height of the ball from where it is dropped is also given, that is 20 centimeter. Now, which formula you will choose to solve this problem? Now, h is equal to 20 by 100 meter. We will use the formula which will work here. V square minus u square is equal to 2gh. The initial velocity is 0. Final velocity we have to find out. 2 into h is 20 by 100. Now v square is equal to 2 into 10 into 20 by 10 into 10. Now cancel, and v is equal to 2 meter per second. Now we have to find out the time. For that we will use v is equal to u plus gt. U is 0, g is 10, and t we have to find out, and this v will come here. Then t is equal to 2 by 10. This implies 0.2 second. The height of the ball from where it is dropped is also given. That is 20 centimeter. Now, which formula you will choose to solve this problem? Now, h is equal to 20 by 100 meter. We will use the formula which will work here. V square minus u square is equal to 2gh. The initial velocity is 0. Final velocity we have to find out. 2 into h is 20 by 100. Now v square is equal to 2 into 10 into 20 by 10 into 10. Now cancel, and v is equal to 2 meter per second. Now we have to find out the time. For that we will use v is equal to u plus gt. U is 0, g is 10, and t we have to find out, and this v will come here. Then t is equal to 2 by 10. This implies 0.2 second. Is t2. Now the total distance traveled will be equal to traveled is equal to x plus x, a to b and back from b to a, and total time taken is equal to total time taken is equal to t1 plus t2. Now we will find out the values of t1 and t2 separately. Then we will put the values of t1 and t2 in the formula. t1 is time taken to go from A to B. The distance between A to B is assumed as x. Then it will be x by average speed. Average speed given in the question is 30 kilometer per hour. And the time T2 is returning back from B to A. Then it will be x by 20. 20 is the average speed between B to A. Now T1 plus T2 is equal to x by 20 plus x by 30. LCM will be 60, 3x plus 2x.